What's going on, YouTube? Welcome back. Today we're going to talk about dissecting portable executable headers. And this room is very important if you're looking to learn malware analysis, particularly static analysis or static malware analysis. As per the description, learn about portable executable files and how their headers work. So the room is kind of stretched in explaining the function of every single header. So we're going to learn a couple tools that are used to analyze the portable executable headers, in addition to learning how to identify the packers. So let's get started. So before we get started, it's very important, guys, again, I'm going to repeat that, to understand the importance of portable executable headers in the malware static analysis process. So how we're going to get started, we're going to start the machine, split the view, and here we are with the machine. We have the samples in here, WannaCry, STR, Redline. We're going to analyze a couple of these samples. So basically, to answer the tasks of this room, you have to analyze this sample. At the same time, optionally, if you want to further extend your knowledge about analyzing portable executable headers, you might be interested in analyzing a sample like WannaCry. Okay, so we can get started by launching PE3, one of the popular tools in analyzing portable executable headers, on this sample. It can take a couple minutes to launch. That's why in the meantime, we can go ahead and use a hex editor to view the sample. As you can see, we got all of this hex representation. So in order to make sense of all of that and understand every single byte in here, we have first to locate or attribute or match the bytes with the headers in the portable executable. For example, let's take an example here. The first header happens to be image dose header. Can be located by, or actually is located, as you can see, if we highlight the first 64 bytes. So 16, here you can see 16, you count 16 bytes, okay, and then here 32, 48, 64. This highlights the first section or the first header, image dose header. As you can see here, image dose header, if you look at the ASCII representation, we have the MZ, which is actually a shortcut for the name of the Microsoft architects who created the MC-DOS, and is represented by the first 2 bytes, as you can see, for the 5A. Now, in the PE3, you would see the same representation, okay, but they are actually reversed due to Indianness. And as you can see, we have this program cannot be run in DOS mode, and these are the hex representation, and this is actually written in the DOS stop. So if the program is not designed to run in DOS mode, and if you run the program in DOS mode, you will get this message. This message, for example, is stored. What happened? It is stored in the DOS stop. Now here we have the PE3 launched, okay, and as you can see on the right pane, on the left pane, we have all of the sections. On the right, we have the details of every single header. So let's expand all of them and we get started. Okay then, so we can start with the first header, since here we are going to explain the function of every single header and whether it is important for malware analysis or not. For example, we start with the DOS header. As you can see, image DOS header. That's the first header. The two most important fields in this header are the eMagic, E_magic, and the E_LFA new. So basically, eMagic indicates the magic number of the portable executable. And as you can see here, the value is 5A4D. If you go back to the portable, or if you go back to the hex representation, it's the same, but it's reversed due to Indianness for the 5A. And as you can see, this is the ASCII representation, MZ. Now, we also told, guys, that MZ is the shortcut for the name of the person. His first name goes by Mark. He's the Microsoft architect who created the MC-DOS format. Okay, and as you can see, we have E_LFA new. It is actually part of the image DOS header, and the address here indicates, as you can see, the value is F8. F8 here denotes the address where the image net headers start. So as you can see, this is the image net headers. So the image net headers starts at this address. So that's how you know the function or the meaning of this field here. And it's also important in malware analysis. So understanding the magic number is very important, guys, to uncover the nature of the file. I know we are analyzing portable executable, and it's pretty straightforward, guys, to know that it's actual executable file, but it's beneficial to look at the magic number first. Sometimes it is not what it seems to be. Okay, that's the image DOS header. Now we go to the next header, DOS stub. Now DOS stub, as you can see, contains the message section. This program cannot be run in DOS mode. And as you can see, we have the entropy, we have the hash, we have the ratio. Note that the size, the hashes, and the entropy shown here by portable executable or by PE3 are not related to the overall file. They are not indicative of the file as a whole, right? It's for the particular section we are analyzing. So it's only for the DOS stub. It's not for the file. Okay. So we mentioned that again, this message can also be seen here. As you can see, this program cannot be run in DOS mode, and this highlights the, as you can see, the hex representation of this message. Where is the, yeah, here it is. And this indicates, as you can see, the DOS stub section. Okay, now after the DOS stub section, we got the image_NT headers. Now this section or this header is very important from the perspective of malware analysis. Are we going to explain why? It contains vital information related to the file itself that we are analyzing, and there are subsections to this header. So the subsections are, as you can see, let's do that. Okay, as you can see, we have NT headers. If we expand NT headers, under that we got the signature, we got the file header, and we got the option header. And I cannot stress enough how these are important in malware analysis, and we're going to explain why. We mentioned, guys, that the image NT headers is located at the address here. This is the address of the image NT headers, if you want to further understand where it starts as far as the hex representation is concerned. Okay, so as you can see, the signature, this indicates the nature of the file. As you can see, it says portable executable. So it gives us what's the nature of the file. In that case, it is portable executable. And actually, the signature is the first 4 bytes of the NT headers. So the NT headers, as we said, it starts here. The first 4 bytes of this is the signature of the file. Happens to be portable executable. Now, the other section is, as you can see, which is subsection of the NT header, is the file header. As you can see, the file header contains information about the file, the machine, number of sections, date, timestamp, and so on and so forth. So these information are also vital for malware analysis. Why? For example, as you can see, the machine field, this is the value of it, I386, which means that the file was compiled to run on 32-bit environment. So the machine field mentions the type of architecture, okay, for which the portable executable file is written. As you can see, it's I386, which means the file is compatible with 32-bit architecture. Okay, number of sections. As you can see, it indicates we have 7 sections. So in these sections, we store code, variables, and other resources. Now we have the time date stamp. This field contains the time and date of the binary compilation. We have this size of optional header. This indicates the size of the optional header section we have here. and in our case it is 224 bytes. Characteristics, very important section under the file header. So it's actually a critical field. This field mentions the different characteristics of the portable executable file. As you can see here, it tells us that the portable executable file has stripped, as you can see, relocation information, line numbers, and local symbols. And also it's an executable image and compatible with 32-bit machine. So the characteristic is another field to look at if you want to understand the nature of the file you are analyzing. Okay, next we have to head over to the optional header. So entry headers, under entry header we have signature, file header, and then we have the optional header. We mentioned that the optional header size is specified here under the size of optional header section. It happens to be 224 bytes. So now we are on the optional headers. Optional also contains important information present in the portable executable. For example, under the optional header we got multiple fields, as you can see. So first we saw the magic. It's the magic numbers. It tells you whether the PE file is 32-bit or 64-bit application. As you can see, the value here is 10B, which means it's 32-bit application. If the value happens to be 20 instead of 10, it means that the file represents 64-bit application. Okay, another critical field here is this one, address of entry point. It's so significant from the malware analysis or reverse engineering perspective. This is the address from where Windows will begin the execution of the first instruction. So this is the address of the first instruction, by the way, address of entry point. Okay, image space, and he refers to the preferred loading address of the portable executable file in memory. So generally it is actually this value, 400,000 in our case. And we have another field here. It is the, let's see here, major operating system, the subsystem. It indicates whether the file has been compiled to run as a graphical user interface or as a command line user interface. In our case, as you can see, it is Windows command line user interface. And here we have another directory or another field. So DL characteristics, number of, we have data directory. So data directory contains, as you can see, information about the import and export of the portable executable. So we have, as you can see, image directory entry import, and we have the entry resource, and we have the image directory entry debug. So these represent the import and export information of the file. As you can see, we have the import address table and export address table. These are the image directory represents these tables, the export and the import address table. So far so forth, we analyzed the image DOS header, the DOS stub. We mentioned the function of image entry headers, where it starts in the memory, and the important fields in here from the perspective of malware analysis. Now let's move on to the other header. So let's collapse these image entry headers, optional header. Now here we go, the image section header. So as you can see, we have some sections that are not clear here. As you will learn later, guys, this is indication that the file has been backed, or there is a packer that has been used to obfuscate these sections. If you see that these sections are kind of not clear, it's not a glitch in the program, rather it is an indication that the file has been packed and an obfuscation technique has been used to obstruct the reverse engineering or the malware analysis process. It's very actually predictive to find these in a sample like that, because this sample is malware. Do not attempt to run this sample in your system. So these sections store information about the code, the icon, the images, the user interface elements. Now normally, As you can see here, you should find the R text. And as you can see, we have R data, R.A data. I summarized all of these guys in my notes file. The note file name is Reverse Engineering Malware Analysis. It's available under the channel membership only, tier 2. And here, as I mentioned, the function of every single section of these. So here they are. So as you can see, our text is kind of obfuscated here. And we have the data. We have it. R data or I data also obfuscated. I cannot see it. N data obfuscated as well. R, and as you can see, R elog and R source. These also are obfuscated. If you expand them, as you can see, you see under every section the same fields. For example, this section is supposed to be R.text, which is generally the section that contains executable code for the application. The most important section in the whole story. R.text under image underscore section underscore header. Our text again contains the executable code for the application. If we look at the characteristics here, okay, that's also important to look at. We have the characteristics of this section. As you can see, execute, read, and write, meaning that this section contains executable code which can be read but cannot be written to. So it can be read and cannot be written to. Execute and read. This is R.text. If you go to R.data here, as you can see, contains initialized data of the application. It has, as you can see, read-write permissions. And it also has execute permissions. These permissions are very important to understand the nature of the file and what it does. Now other sections here, as you can see, they are obfuscated, but let's explain them here. So we have .text, we explained that, .data, R data, I data. These sections often contain the import information of the portable executable file. Input information helps a PE file import functions from other files or Windows API. Specifically, we're talking about DLLs. If we try to find that, this is supposed to be the R.data. As you can see, execute, read, write. In every section, we can see execute, read, write. So this is very obvious that this file needs multitude of permissions. Execute, read, write. Yeah. Now what about let's see. So yeah, this section again, guys, is also very important in the malware analysis process. Now if we expand the R text again, as you can see, we have the virtual address, and also we have the entropy, characteristics, and the size of raw data. Now virtual address indicates the section's relative virtual address in the memory, right? And here we have the virtual size, indicates the section size once loaded in the memory. I know you cannot memorize these, but you have to have some sort of cheat sheet that explains the function of all of these headers and all the subsections under them. And again, we mentioned, guys, that the characteristics is important. Entropy. Now entropy indicates the randomness of the data in the file. The higher the entropy, the higher the randomness of the data, and the more likely that the file has been, or the binary has been, obfuscated. So obfuscation is not always an indication of malicious activity. Software developers use obfuscation and packers to protect the file from being reverse engineered or cracked. You know, some softwares have licenses. In order to prevent the license from being leaked or to prevent a crack from being generated, software engineers use obfuscation. So when you see the value of the entropy is more than 7 and is approaching 8, it means that there is a high level of randomness of the data in the file, which means obfuscation has been used in the file to protect the file or to actually obstruct reverse engineers from analyzing the file because it is malware, you know. So image section header. Next, we have image import descriptor. Okay, here you go. You find all the DLLs loaded by the file, all the binary. As you know, sometimes the binary itself cannot perform its function using its own functionality. It has sometimes to rely on Windows API calls and import some DLLs to perform specific functions. Now, every single DLL here, as you can see, it has all of the API calls. So these represent the DLLs, right? Now, more important than the DLLs, we are actually sometimes interested in finding the API calls that are used by the DLL. So this actually can be found under the first thunk. The first thunk, under that we have all of the API calls. As you can see, we get process address. This is an API call, and also we have, seems like the file gets stuck. Let's wait a bit. Okay, user32DLL, send message. This is an API call. These API calls are very important in further analyzing the behavior of the file. You can find if you are stuck and you don't know and you don't know the function. This is so, let me close this one. Okay, if you cannot find out or you don't understand the nature of this API call, you can just use Microsoft documentation, or you can just Google it and get more information about the nature of this API call to further supplement your understanding of the nature of the file. Okay then. So to summarize, I have here in my notepad I have summarized the important sections to pay attention to when you statically analyze the malware. We said it's image import descriptor, tells us all of the, as you can see, the DLLs imported by the file along with the API calls made. Image underscore nt underscore headers, specifically here we look for the signature, the file header, and the option headers to understand the nature of the file. Is it executable, the size, the entropy, so on and so forth. Image section header, we look specifically at audio text section, size of raw data, and miscellaneous underscore virtual size. Now these are important, as you can see, to identify if the file is backed or obfuscated. Again, also we talked about the entropy. And also I mentioned here, guys, the signs that a file is obfuscated or malware analysis evasion techniques. Now, obfuscation and backing obfuscation is a method of evading analysis. It's not the only method, it's only one. There are other methods as well. I mentioned them in the note file. Let's go ahead and answer the questions of this room after we have gone over all of the concepts. Task 2, the questions. Let's see. What data type are the PE headers? Struct. It's mentioned here. Okay, the next one. How many bytes are present in the image dose header? We said it is 64. What does MZ stand for? The author of the Microsoft dose. In what variable of the image underscore dose underscore header is the address of the image underscore nt underscore headers? We said it is this one. In the attached VM, we open the PE file. This is the file you need to open. What's the address of image underscore nt underscore headers of this PE file? Let's see. So we go to image underscore dose header and we locate this field. It is the one that ends with F8. Task 4. In the attached VM, there is a file, desktop samples. Open this file in PE3. Is this PE file compiled for 32-bit machine or 64-bit? How to do that? We have to look at, the image nt headers. Specifically, we look at file header and then we locate the machine section. It is compiled for, as you can see, 32-bit. What's the time date stamp of this file? Now, as you know, time date stamp represents the time at which the file has been compiled, and here, as you can see, it indicates this value. Optional header. Which variable from the optional header indicates whether the file is a 32-bit or 64-bit? Well, we, as you can see, expand the optional header, and it is actually the magic number. What magic value indicates that the file is a 64-bit application? Well, As you know, when it is 10b, it means it's 32. When it's 64, when it is 20, it means it is 64-bit. So it is, as you can see, 20b indicates that the file is 64-bit application. What's the subsystem of the file? The subsystem is here. As you can see, the file is made to run as a command line user interface. Image section header task. How many sections does the file have? Let's locate now the image section header, and here we can locate the number of sections. Wait, how many sections does the file have? Oh, here, it's 7 under the file header. What are the characteristics of the R source section of the file? Now, to find the sections, we have to expand, as you can see, the image section header, and we're looking at the R source. Expand this one, and we can see here the characteristics: execute, read, and write. Import descriptor header. The P file. Oh, here you have to open the redline file. Imports the function create Windows exw. From which DLL file does it import this function? Well, guys, if I'm going to open this file now, it's going to take time. So you can find that by expanding the corresponding header responsible for displaying the DLLs, as you can see. Now here the question is, what DLL calls this API? You have to expand all of the DLLs to find this, and expand these DLLs and look for this API call. You will find it is the user32 DLL. Maybe if you do that here, let's see this executable. It doesn't, but on the redline executable it does call this API. Packing and identifying packed executables. Which of the files in the attached VM in the directory desktop seems to be packed executable? Well, it is the file we are analyzing here. Why? Because one indication that the file is packed is unclear, as you can see, data sections. It means that the file has been obfuscated. So that was it, guys, for today. I hope you liked the video, and I will see you later.